Hey kids, it's Friday night. It's Good Friday night, about 11 o'clock, and I got some time, so I thought I would uh, do a video on the review worksheet. We'll be going over this in class on Wednesday and have the test on Thursday during our Zoom class. But I thought you could use the extra review. That way you can pause it, rewind it, all that. So I'm going to go through the worksheet. You're going to be assigned 1 through 20. I think I'll go through the even problems right now, and then between this and what you ask in class on Tuesday or Wednesday, I guess, you'll be all set. So here comes our review off the worksheet, which is exactly like the test. So here's problem 2. It says list two angles, one positive and one negative, that are coterminal with negative 160. So coterminal means same terminal side. So where's negative 160? Negative, we go this way, is 90. All the way to there would be 180, so let's call it a little short of that. Close enough. So that's negative 160. What's coterminal with that? Well, for the positive one, we go the opposite way, counterclockwise. And what would that positive angle be? It would be 200. And I don't use a formula, subtract from 360, 360 minus the angle. I just say these two absolute values have to add up to 360. So 200 is one of the answers. The other answer is they want another coterminal that's negative. So what we do is just take an extra lap around. This 360 plus another 160. That would be negative 520. So to get that second coterminal one, we just take the extra lap. One lap around is 360, and then another 160 more, all in the negative direction, so total of 520. So those are your two answers for number 2. All right, here's number 4. Number 4 says change this to degrees with a decimal, 131 point something. Remember, you got two choices. Either going to take this and multiply by 60 or divide by 60. Well, multiplying by 60 is not going to make it a decimal. It's going to make it a huge number. So let's divide it by 60. And 48 over 60 is exactly 0.8. So our answer is 131.8 degrees. Now, what if it didn't come out 0.8? Let's say it came out 0.8273. I know it didn't. It came out exactly 0.8, but let's just pretend. Well, if we're rounding to one decimal place, like it says, I put my arrow there. I look at the next number. It's less than 5, so it's staying 8 anyway. If it was this, it would bump up to 0.9. That's simple rounding. All right, that's number 4. Let's go on to number 6, which is the opposite. Now we're going to take that negative 251.77 and change it into negative 251 in some number of minutes. Well, in this case, you multiply by 60. Whatever that comes out to be, I think it's 46.2. So to the nearest minute, it would be negative 251 degrees and 46 minutes. Rounding that to the nearest whole degree. Closer to 46 than it is to 47. So that's your answer there. All right, moving right along. 7 and 8 are about co-functions. 8's a little hard to read, but that's 47 degrees. So we want to find this angle phi. Well, it's co-functions complementary. Co-functions have to do with complementary. Co-functions complementary. So if two angles are co-functions, sine, cosine, tangent, cotangent, secant, cosecant, then the trig function of one of the angles equals the complementary of the cofunction of its complementary angle. I'll say that again. If you take the trig function of one angle, like tangent, then its cofunction would be equal to it if these two angles are complementary. Simply 90 minus 47 is 43. I use too many words to describe that. It's simply, if it's cofunction, tangent, cotangent, then these two have to add up to 90. So 90 minus 47 is 43. Okay, next page. These are our special right triangles, 30, 60, 90, or 45, 45, 90. Number 10 asks for cotangent of 45. A 45, 45, 90 triangle works like this. Or Ms. Baines might have shown it to you this way. Call these sides 1, 1, and this root 2. I'll show you both ways. Using the black letters, the X's. Here's how it works. Cotangent, well, we don't know much about cotangent or cosecant or secant. All we know is they are reciprocals of other functions. So we know cotangent is reciprocal tangent. So let's find tangent 45, get an answer, and we'll just flip it over for cotangent. Well, tangent is what? It's opposite over adjacent. Opposite over adjacent. So for this angle 45, opposite is x over adjacent x over x is 1. If you use the blue numbers, opposite over adjacent, 1 over 1 is still 1. So tangent of 45 is 1. So cotangent, it's reciprocal. What's the reciprocal of this? Well, it's still 1. The reciprocal of 1 is 1. So cotangent 45 is 1. And then number 12 is also a 45. It's cosecant 45. Don't know much about cosecant other than it's the reciprocal of sine. Let's find sine 45. So here's a 45. Use this one. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So sine is x over x root 2. Okay? Opposite over hypotenuse. Well, that reduces to 1 over root 2. Now, if I just wanted sine, and only sine, then I would rationalize that. But really, I'm going for cosecant. So whenever I get sine, I'm going to have to flip it over anyway. Might as well flip it now. So flip this over, and you just get square root of 2 over 1. So cosecant of 45 is root 2. So let me give you that one more time. Sine is opposite over hypotenuse. So sine was x over x root 2, which reduces to 1 over root 2, which would rationalize to this, but no need to do that because we're going to take that reciprocal anyway to get cosecant. Okay? Let me do number 11 since that's a 36 90 triangle.